Today we're going to look at two confidence interval calculations. The first one goes like this. The average amount of money spent by a sample of 25 drivers in 1 week on gas was found to be $57, with a standard deviation of $2.36. Construct a 90% confidence interval for the population mean. So what we need to do is we need to calculate the margin of error here. The error term is the critical value from the t distribution times the sample standard deviation of the square root of n. So let's see what we know. We know that the mean is $57. We know that the standard deviation is $2.36. We know that the sample size is 25. We know that the degree of freedom is n-1, so that's 24. The confidence level is 90% or 0.9. We need to find alpha because that's what we need for our t inverse function. And so alpha is 1 minus c, so that's equal to 1 minus 0.9, making it 0.1. And now to get tc, we're going to go to our functions and we're going to use t.inverse.2t. So the probability is 0.1, that's alpha there, and we need the degree of freedom, which is 24. So our critical value is 1.711, and here's how we got those guys. And now to calculate our margin of error, we're just going to use this formula right here. So we're going to say it equals t critical, which is 1.711, times the standard deviation, which is 2.36, divided by the square root of the sample size, which is 25. So our margin of error comes out to be 0.808. In real terms, that would be 81 cents. So to get the lower limit for our confidence interval, that's going to be our original mean minus the margin of error. So we're going to say equals 57 minus 0.808. And to get our upper limit, it's going to be 57 plus 0.808. Those are both money. Here's how we got them. So our confidence interval is going to be 56.19, 57.81. And now we're going to provide an interpretation from that. So what we're going to say here is that we are 90% confident that the true population mean amount of money spent on gas is between $56.19 and $57.81. Okay, let's go to problem 2. So on problem 2, suppose you're thinking of becoming a pet owner and want to know the amount of time people spend caring for their pets. You survey 20 pet owners and you find that the average amount of time they spend caring for the animals was 108 minutes per day, with a standard deviation of 17 minutes. Construct a 95% confidence interval for the amount of time pet owners spend on their animals per day. Alright, so the mean was 108 minutes, the standard deviation was 17 minutes, sample size was 20, that makes the degree of freedom 20 minus 1 or 19, the confidence level was 95% or 0.95, alpha is 1 minus c, so that's equal to 1 minus 0.95 or 0.05, and now again we need to use our t dot inverse dot 2t. Probability 0.05, degree of freedom 19, and we get 2.093 for our confidence for that. And let's see how we got these. Okay, now our margin of error, again, here's the formula. It's the critical value of t times the standard deviation over the square root of the sample size. So it's equal to 2.093 times 17 divided by the square root of 20. And that comes out to 7.96. There's that calculation. And now our lower limit is going to be 108 minus 7.96. Our upper limit is going to be 108 plus 7.96. And there we have our lower and upper limits. Here's how we got them. And now our confidence interval is going to be 100.04, comma 115.96. And now we're going to write our conclusion. And we're going to say that we are 95% confident that the true population mean amount of time people spend caring for their pets is between 100.04 and 115.96 minutes per day, or roughly between 100 minutes and 116 minutes per day. Hope that helps. Have a good one.